Hello. So I wanted to give you an overview of what we've been doing internally. I'm going to try and cover some of the technical details. If you want to know more on some detail, some really technical ones, I might ask to take it offline. I'm usually quite open to share, but obviously some of the things that we've developed are sort of proprietary. The cover of the image is where we're based in Marritt. So one of the joys of working at a technology firm is with global clients is you can be based anywhere. So we chose to be based in the mountains. So the challenge we have, our clients are big global firms, typically with over 20,000 employees, in many instances over 100,000 employees. And big firms have frequently and for a long time asked employees for opinions. Over the last 20 years, most of the employee surveys have been based on psychology models and have been mainly scale questions. Earlier days, they were much more open text and upwards consulting, and we're seeing a move towards that, especially as there's a whole variety of factors which increase the desire for organizations to learn from their employees. So in some countries, it's regulatory requirements. Others, there's things like corporate and social responsibility, which means that instead of just managing for stakeholders, for shareholders rather, they manage for a variety of stakeholders. We also found when we were working with clients that they tended to take action much more based on the answers in text format than the sort of scale questions that we did. The text has a lot more richness to it, and this prompts senior executives to feel like they can act just on that. So in a large corporate, on a traditional survey, they might have found out communication is an issue from a Likert types question. They wouldn't have known what about communication is, so they've then rolled out workshops around the world to explore this theme. With text, there's usually enough information in the text for an executive to feel confident they can make a reasonable decision. So we're seeing a industry shift from very long, boring surveys. If anyone's in corporate world, you might have seen these sort of 60, 70 question annual surveys. We're shifting to much smaller questions, more reliance on open text, and probably more frequent as well. For our clients, one of the key things that they want to do is ask any question. And therefore, we had to be able to help them understand the answers to a question, not necessarily on the traditional themes that they might have asked, but on anything. In fact, what we found is that as we help clients understand text, the executives have a much greater desire to ask more open questions. So we start by them feeling they have to do surveys because there's regulatory requirements, and then we often have to temper their enthusiasm because they suddenly realize they can ask vast numbers of employees some of the pressing issues that they have. We wanted to try and do themes rather than topics, and the way that we look at it is that the way that the theme that we provide should be a reasonable answer to the question itself. So if we look at a traditional model that's being used in many survey tools, it will identify this is about communication or this is about pay. But we feel that you need to go the next step and say, what is it about communication? And this is really important when a topic or a theme can be used in multiple ways. So one of our clients recently, we had a big number of people talking about communication. Part of it, we're talking about wanting more transparent communication from senior leadership. Part, we're talking about better communication within departments, and that was linked to to themes around collaboration. And another group were talking about they wanted less emails at the weekend. Right? And the action that you need to take for all of those three things is different. So bringing them together and just calling them more communication doesn't necessarily work. What else do we see within the data? It won't surprise you, but employees don't write in full nice sentences. Depending on the organization, it goes from text speak with lots of emojis through to some of our pharmaceutical clients who I suspect half their R&D team have PhDs and insist on writing sentences of about 300 words and multiple clauses. So we get a whole range of things. And we also get some bad spelling, as you would imagine. And sometimes those spellings are, they mix up words. So the most common and most amusing one for us is that there's a large percentage of people who can't differentiate between morals and morale, which you can imagine some of the uses of having bad morals in their department. Many of our clients are global, so we're often dealing with about 15 different languages coming through. I would call it a medium-sized data set. So I think the smallest we tend to work with is about 1,000 or 2,000 answers. We can quite easily be getting over 100,000 answers. So they're big enough to cause issues, but probably small enough that, in modern machine learning terms, would not be counted as a large data set. We also need to look at really quick turnaround. So an example recently we had was a survey closed with a client on US time zone end of day on a Friday. We got the data on a Saturday morning. We had a briefing call with the client at Monday lunchtime. And it was going to go to the chief exec on Tuesday morning at 8 o'clock. So we were able then to take a sort of early cut of the data halfway through the survey process to start understanding what was going on. And of course, HR departments don't have a lot of money. That they always seem to be, can you do everything cheaper? So our clients don't have a vast amount of resource. We can't build a team of 100 people. We've looked at a few hypotheses. One is that we can get more accuracy by building specific model for the question rather than using generic models. And this is partly because we view that you need to interpret the answer properly, you need to understand what was asked, especially in instances where people aren't writing in full sentences. They assume that you understand, when they're writing, they assume that you understand and link it to what was asked. The second hypothesis that we use, and this we started doing about 2 years ago, and it was from a time I read a book by Garry Kasparov talking about chess and how a decent chess player plus a chess computer could outperform either a grandmaster or a chess computer. And we sort of took the same approach and said, okay, let's work out how do we use humans in this process and use the algorithms to augment what they do rather than with the aim of trying to replace them completely. And our final assumption is that people in organizations develop their own language. So you can think about this as acronyms. Some of our clients give us tables of acronyms of hundreds and hundreds of acronyms they use in their organization, often the same acronym with multiple meanings. They have project names. Sometimes they just plain misuse language. So a retailer client talks about payroll when they actually mean headcount. Because if the store manager has a greater payroll, they can afford more people. So when they want more payroll, they actually want more staff. An Indian client talks about structure when they mean pay. Because in India, they need to define how they're paid to get an efficient tax structure. So we also, as well as building models at the question level, we build them mostly at the organization level, because then we can learn those type of things. In terms of coding, we therefore have two variables that we're trying to optimize on this. Sorry, I'm an economist by background, so I'm always thinking about marginal variables. But we're looking at not only the quality of the results we develop on the clients, but how much human effort do we have to put in to build a good coding model. And we're obviously trying to minimize the amount of human time to get the highest level of quality. And I've defined a simple, decreasing marginal returns, which you probably all can imagine of amount of coding time, and also how we present that data for coding. So not only the instances labeled, but how do we present those instances so they can be labeled quickly. And that's what we're trying to look at. So if we think about other ways of labeling data, and if I take the example of Mechanical Turk, which for most instances I believe is, people are using it in a pretty non-sophisticated way. You have a whole bunch of tasks and you allocate it to people, but there's no learning built into that model. So the model isn't identifying which tasks to provide. The Mechanical Turk folks are generally non-specialized. It's people earning a tiny amounts of money per tasks. Our clients would have issues with data confidentiality and security. Often this is counted as personally identifying information, so we have to be very constrained. And the assumption is that coding is cheap and therefore you can just do as much of it as possible. So our approach, especially when we understand that, if you want to understand the answer to a question about finance, it's really valuable to have somebody who's doing that coding who understands finance, right? So can understand the terminology there. And the confidentiality. So we assume the coders are expensive, and therefore, how can we use as little of them as possible to get the maximum amount of benefit? So I've tried to do a sort of a super high-level approach to our process, and I suspect we can go into some of these questions at the end. The pre-processing for us includes a bit of spelling correction. It includes automated translation, or detecting what languages and then automatically translating, and then creating a much larger set of data than was originally planned. So we break the answers down into sentences. We then look at clauses. If there's a list, for example, I want more pay, training, and holidays, we would create a sentence saying, I want more pay, I want more training, I want more holidays, because that increases the coding. We then perform an unsupervised clustering to identify what are the themes within this text. And we're looking really in terms of, what are the important words within that clause that define that. And we've got some algorithms that we found successful at finding different types of chunks of words there. And then we'll use an embedding approach to sort of expand out that approach. So we might identify that more pay is there, and the expanding approach will sort of say, okay, we also want increased salary, right? So we're looking at closeness metrics there. We have a limited amount of success in terms of trying to increase the size of training sets. So one approach that we've had some success with in terms of single-figure percentage increases is when you've got a training set, doing this language loop and sending it out and saying, okay, translate it to another language and then bring it back into English. What improvement will we get there? It depends on the language approach. We've had limited success. If it was English to German and then back, we've tried doing out in Google and back on Microsoft and often found word to word, the same, which is no use. So some languages which are based on different linguistics, like Russian, has a lot more success than a European to European, Western European to Western European language. Then we have this approach where we're creating the classification model. In fact, we do multiple binary models. So we have a model for pay, model for training, model for whatever the other ones. We generally do only about 70, 80 different models. And then we're getting the model to suggest which ones to give to a human for refining the training set. And I'll come into that. And then the other part, one of the things that we're really conscious about is that humans are much more tolerant for you to say, we don't know what this is about, than to say it's about training when it's actually about salary, right? So we set it up so that it tries to get as few false positives as possible. But then what that means is there's a whole bunch of text that we haven't been able to code, and we look at doing additional analysis there, some of which is around clustering, right? So if you take out the clustered data, then you sort of amplify the signal in the unclustered data, and you can do another clustering routine there, and it identifies new themes. And then finally, we'll link it to other data, who's the person in the organization, not in terms of individuals, but is this a male, female? Is this somebody working in finance or someone working IT? So we can identify which themes are more common in different groups. So one of the things that we like doing is sort of visualizing these predictions and sort of trying to identify. So, if we're looking at the sort of active learning, one area is we want to look at the spaces where about 50% are right and 50% are wrong, because that's maximizing the inputs for the human. Now, a lot of the literature says, if you look at 50% confidence, then that's probably right? That's what it's saying. In fact, what we found is that there are different elbows on these probability curves, and you're better off looking here on the lower part of the lower elbow to identify areas where about 50% are right and 50% are wrong. And depending on the shape of the curve, so we're looking at a sort of a cumulative distribution of probabilities, then we can look by the shape and work out what we need to do to each model. Right? So you start seeing some patterns here. We're also analyzing how a set of predictions, we usually batch it into 5 or 10, changes the overall probability. So if we give them another 10 training examples, how does that shift the model, the probabilities of the codes? So we've been building internal tools so we can build these models as quickly as possible. There are tools out there on the market. There's a tool called Prodigy by makers of Spacey, for example. So one of the things that we did early on was try to work out, do we just buy Prodigy and use that, or do we create it ourselves? We decided to create it ourselves. And for certain reasons. Firstly, we want to provision data to different people. So a finance question might go to a finance expert. There might be one of our team who can look at some clients but can't do other clients. And we wanted to control access. And by building it ourselves did that controlling access. We also wanted to take the data scientist out of the loop completely. And Prodigy was built very much for a data scientist to quickly start building a trading set themselves. And it does require, when you get it running, you don't need to be a data scientist, but to set it up, you at least need to know some basics of Python code. We wanted to add the visualizations and to focus there. I think the Prodigy focuses on the sort of 0.5 confidence levels. We also wanted to help us minimize the human input. We wanted to measure how long it was taking and the productivity of those people. So we're not trying to sort of be tough on people and say, Sam, you're taking twice as long as Tony on doing this because there's so many unknown variables there. But we wanted to be able to measure it and sort of see if we make changes to the inputs, what level does that have on productivity? So for example, sending short sentences is easier to code than if you've got a long sentence, for example. And there's a cost effect. So I think Prodigy was about $500 for a license. If we've got 10 people, then they didn't require too many people before our estimated cost on building meant that we could just expand in a much more cost-effective way than using existing systems. So you have a sort of screenshot. We designed it for mobile phone, but actually it works better on. And productivity works better on a bigger size screen. In terms of the insight, so creating the themes is one thing, but we found that the biggest question for our clients was, so what? Right? So just knowing that 20% of people talk about communication isn't terribly interesting. What's often more interesting for them is to understand what else they talk about. So co-occurrence is something we found that's often very, very useful to show. We use a graph-based approach and do community detection. We also want to provide clients with the way of, if they're going to and presenting to an executive and they say, okay, what did you mean by this theme? we can give examples there. So we use a summarizing text approach. Sometimes we weight it with other things rather than just pure summarized text. So for example, we weight it by emotion, right? So because executives like things that really grasp the heart or show pain or show joy. So we don't necessarily, some clients we want to give very neutral things. Some clients we know that they just want to have something that's really going to pull on the heartstrings because that'll get the action. So what has worked well? We work extensively with domain-specific embeddings. So the thought process here is that we have a lot smaller data set than most of the embedding models are created in. However, we have a really narrow definition of text, right? And in the smallest level, we have just the text that's providing about that question. If we've asked about what could we do to improve customer service, we know the answers around customer service. And the sort of larger embeddings, that reduces out whole parts of the problem. And the issue in terms of homonyms and things goes away largely because people talking about the words in certain use cases, right? So in a financial market, financial industry, we're not going to have Bank of a River, right? We're just going to be having the bank, for example. The second one, and this is an approach that I like, which is a good indication, is the sort of Toyota versus Tesla approach. We use really lo-fi tools to try and get the process working well before starting building it into our tools. So we use a lot of Google Sheets, sending things to Google Sheets. The Toyota versus Tesla approach is that, my understanding is Toyota fixes how they're going to build a car quite manually and then starts automating, whereas Tesla went and tried to automate everything before running the process lots and had production issues. And then finally, experiment. I spend a lot of time reading papers, and then I annoy my analyst by saying, could we try this thing? And some work really well, and some don't. And getting a culture of just trying things and trying to identify which parts of the process would benefit has worked really, really well for us. We don't see the benefits that some of the papers have. Just because a paper is reporting a benefit overall on some other data set doesn't mean on our data set you get the same improvements. I heard next door's finishing, so I'm supposed we're on 2 minutes. So what have we got next? So there's a question in some of it is, can we automatically label text, right? Can we look at a piece of text which is uncertain, but then apply a machine learning technique or an analytics technique on the metadata of that and identify which ones have greater value if we send to individuals? So a very simple rule that we have is on one round, if we take something with a 95% confidence on a prediction and add that straight to the training set, then that usually works reasonably well. The second round, it doesn't. Right? And what we're trying to do is trying to avoid the semantic creep within there. But are there other rules there that we can identify using metadata on the text to identify which ones would have greater impact? And that's linked very much to this better models for uncertainty. I said that 50% isn't actually, for our experience, ones where 50% are right and 50% are wrong. So can we work out that? And we're looking at ensemble techniques here and sort of say, okay, instead of a voting rule, can that voting rule be human? There's an awful lot of benefit for us changing the UI tools and the UI of it and seeing how small changes to UI increases worker productivity. And then final thing is that we've got some themes that we know within data that are really rare and therefore hard to build a training model from an inductive approach. Bullying, for example, would be one example. In the US, there's legal obligations to act if you hear something around bullying, so we need to be absolutely brilliant at correcting that. But in most data sets, we never hear about it. So can we use an approach to amalgamate all of our data to build really good models on some of these themes that we can then apply to everything? So contact details very small. Grab me on LinkedIn. I'm really happy. if you fancy some time in the Engadine, we haven't at the moment, but we might be looking at internships. So we like working hard and playing hard. I have no problems with people coming in the winter at 10:30 because they've gone skiing in the morning. And if you're doing some research at university and you want to talk about real business problems and potentially some of our data sets, then let me know.
Thank you very much. Are there some questions?
You mentioned random ethics.
Yes.
What kind of model are you using?
So we found that at the moment we're using mostly fast text. That's partly because our experience, and if you have different experience, I'd love to hear it. Our experience is it's quick to build a custom model, and time is obviously one of the things. I didn't go into enough detail on the custom models. What we find is we can use them for interesting use cases. So for example, one of the things that we found recently was a client who the model automatically identified that arrays meant pay, just because of the way that raise was being used mostly along with pay in the document. So it finds that. The other alternative is using closeness on themes such as what are people talking about Brexit. Then we found out that that theme around Brexit was linked to job losses and things like that. And the clients can come to us, and that's the advantage of using, for us, a custom model. We tend to have 4. So we have the overall pre-built models you can have. We have a model that we've developed over a data set, over all our data sets, which are increased every time we get a news data set. We have a client-related one, which does well on things like client-specific terminology, and then we have a custom-related, question-related model. And what we'll do is play around the same questions across different embedding models and look at that. But we use fast text mainly because of the speed.
Okay, no question anymore. Most of you will be hungry. Thank you very much.
Pleasure.
For listening. Thank you much for your presentation.